Hi, everyone. Good afternoon, everyone. And thank you for joining us on this really brilliant, hot summer day here in Vancouver. And hopefully for all of you who are not in British Columbia, you're enjoying some really awesome summer weather. This is truly the domain of the committed, because you have all taken time today to kind of be with us on this sort of inaugural discovery session. We had a session just about a week and a bit ago where we talked about some of our phase 2 plans. And for those of you who were not part of that session, I'm going to start with a little recap of what we talked about last time. And we are a small but mighty group today, so we'll probably have an opportunity to kind of go around the table a little bit. For all those who are not shy, just feel free to unmute your camera and wave and say hello. Ian Evans, who is working with me on this phase 2 sort of strategy and workshop, will probably facilitate the discovery portion of this discussion. We may call upon some of the folks that we know well, who we think will have some contributions to be made here just to get us kicked off. So let me first start by sharing a little bit of what we talked about last time. You just give me a moment to do that. Hey, Raymond, great to see you. Okay, everyone see my screen? Just nod, Annika, if you can see that. Okay, fantastic, great. So last time we held a bit of a town hall just to say that thanks to everyone here on this call, the entire Digital Supercluster community, we've made some fantastic progress over the last 4 years. And our objective is really just to gather insights, perspectives towards our strategy for the second phase. We're putting together an application where we get our portion of the $750 million that the Government of Canada has set aside for a renewed undertaking, the Global Innovation Cluster Initiative. And that's what we're here to talk about. So last time we kind of shared a kind of a high level themes and areas of focus roadmap here. And there were some other comments that were made during the discussion where we may look at expanding some of these areas. There's some really interesting themes that are coming out from the projects that we're involved with. But for the purpose of today, we're going to focus on the first bucket in the critical minerals space. And again, this is in alignment with Canada's overall goals. And I think the clean tech agenda, net zero agenda, to try to significantly increase the supply of critical minerals and Canadian-based minerals towards the green and digital economy. And part of this is with a sustainability lens in mind, and an enhancement of what it's going to take in terms of value chains and some of the technologies underpinning all of that. So we're going to focus on that. The other areas we did talk about was, of course, a continuation of what we've been doing on health, in particular about expanding access, improving outcomes, and really enhancing the sustainability of healthcare. Digital decarbonization, we talked about briefly, which was really somewhat intermixed with this idea of critical minerals, more from a holistic standpoint of how we can help with some of the natural resources industries and some of the industrial segments to decarbonize. And I think we also did talk about the digital skills and what's needed for the talent base and the new digital economy. But for today, we'll focus on the first column. Now, what we did do was we just gave a couple of examples of where the opportunities might be. And this is really very much just a placeholder. I'm hoping that through today's discussion, you guys will contribute towards sort of an expanded set of opportunities that we might explore, or maybe we'll take each one of these areas and maybe unpack it a little bit to determine where the areas might more specifically be of interest. So in the first category, we talked about, well, certainly if we're talking about sustainability, then low impact exploration is part of that, the use of digital technologies to advance those goals. And it's not just sort of the exploration of stuff, it's also the analytics and the modeling that would go behind that. The second category we talked about last time was just how you can make for more efficient extraction mechanisms and just the whole production side of the mining industry. Those are supply chain related, but also the management of facilities and assets and resources. And so that's all in sort of the mine operations pieces. And then, of course, downstream, as you look at the value chain, is how does this all feed into the approach of using these critical minerals towards sort of refined products that can then go into various as key ingredients towards the manufacturing of clean tech sort of supplies and services. So what I would like to do now is kind of just pose a couple of anchor points. We took a look at what Canada's critical minerals strategy looks like, and the strategy really has 6 areas of focus. First of all, it's around driving research, innovation, exploration, accelerating project development, building sustainable infrastructure, advancing Indigenous reconciliation, growing a diverse workforce and prosperous communities, and strengthening global leadership and security. Now, not all of these tie directly to what we're talking about in digital, but our hope is that it provides a frame for the kinds of things that we can contribute towards. So a few questions before I hand it off to Ian, and then I think he's going to take us through the workshop portion of this. So just for some discussion, certainly one of the things is you look at the strategic pillars of the critical minerals plan. What is the role that digital can play to advance that whole strategy? I think one of the areas where we're hoping that you can contribute towards is a conversation about where the major challenges might lie and how our framework for collaborative innovation might play a role in solving some of those challenges. And finally, because we are really set on ensuring that these are not just research projects that don't have a commercialization outcome, but rather has a built-in environment in which industry can invest and participate in the outcomes and also adopt the solutions on the other end of it. So the final question is, where is there potential for industry investment at scale? So that's just some framing stuff we want to do here. I'm going to pull down the screen for a moment so I can see everybody again and see if there's any questions at this point, comments people might have. And feel free, again, if you want to unmute your camera and wave and say hello. We're a small group today. We're about 20, 25 people. So welcome to the discussion. Oh, there's a hand. Emily, thank you for being the first to chime in.
Hi there, no problem. Question today, I did ask it in the chat, is the geographic scope of the conversation. So I'm aware that the Digital Supercluster is federal in scope. Does that mean that this is supporting like a country-wide discussion today, or is it scoped to a specific region? From your nods, it looks like it's countrywide.
It's countrywide, and I think I'd take it further and say, if we can establish, ultimately we're trying to invest in digital innovations that have potential to help the strategic goals here in Canada, but then ultimately can get exported around the world. So I know that's a lot of work, Emily, that you guys do as well. So it's sort of a domestic orientation on a problem set, but then with global markets in mind.
And then how to make that work with all the provinces underneath and the
local
and Indigenous governments. Yeah, absolutely.
No question. There's a lot of complexity in how we have governance pieces, but that's why we have great minds that are working together on these problems.
Thank you.
And I'm not sure if there are any other comments in the chat or questions. Annika, if you see any, just flag me.
Nope, we're good for now.
We're good for now. Okay, great. If there aren't any other questions or comments, then let me turn it to Ian, who's going to get you guys to kind of open up your creative spaces in your minds, and let's see if we can have a conversation about some of the opportunities here.
Thanks, Bill. Hi, everyone. Great, and thank you for joining us today. As Bill's alluded to, the critical minerals strategy really talks about the digital economy as a recipient of critical minerals, and the critical minerals industry, not really, it's not explicitly articulated as a beneficiary of the digital technologies that we hope to bring to bear. And as a co-investor in the natural resource sector and the digital technologies that support that, obviously we have a very high level of interest in what digital technologies can we bring on, how can we target those to challenges that are meaningful for the industry, how can they overcome those challenges as a consortium-based approach, and how do we ensure that we put them on a trajectory that allows them to become recurring revenue generators within Canada. So that's really where we're going to take the discussion today is, where do we believe those areas to be? We've kind of as Bill's articulated, 3 big buckets of find where the minerals are, try and extract them in the most efficient way, and then refine them so they can get to market and to end product manufacturers as quickly as possible. So part of today's exercise will be testing that hypothesis. Part of today's exercise will be drilling in a little bit to understand what are the challenges that are inhibiting the realization of that using digital technologies, and what we can actually do about that. So I'm going to just share my screen, and I'll take notes as we kind of drill into this. I think that's probably the best place to start. So we have a few faces and names that I recognize on the call. So maybe what I'll do is actually start by Francis, if you don't mind, if I can pick on you, because I've worked with you in the past on a number of projects.
Sure.
And I think it might be useful for those who don't know Metaspectral, if you could just give a quick intro on what Metaspectral does, and then what you hope to achieve in the critical mineral strategy, and how what's perhaps inhibited you from engaging further so far.
Yeah. Hi everyone. Turn on my video so you put the face to the name. Hi everyone. I'm Francis Dumais. I'm CEO of Metaspectral, and we basically use ultra high definition infrared technology to essentially detect objects, features, and characteristics that are invisible to traditional computer vision. So this kind of technology is typically called hyperspectral data in the industry, if you've heard about that term. And as it relates to this field here, it really allows us to not only identify that there's the sediment of interest, but it also allows us to identify what those minerals may be. And that can be done from the air, or it can be done also on the ground. Once a core has been extracted, we can also potentially analyze that core and very accurately identify the different minerals within that core. Ian, your second question was what was preventing us from kind of entering this industry? Is that correct?
Yeah, that's right. Yeah.
Okay. Yeah. So we've definitely had interest, maybe from other companies that have mainly so far focused just on just more research related. So we're really looking. I think what was missing for us is this critical mass of companies or partners that is ready to take this technology and implement it in a large scale production environment.
So just to articulate that in perhaps a different way, like the challenge that you face is really having people sufficiently driven to move from a nice research use case study into something that's production ready. Is that a...
Yeah, that's correct. And I think part of it has to do also with just access to this kind of customer base or stakeholder is probably a better word. Access to stakeholders that would have the best interest in moving this project into a larger scale implementation.
Great, thanks, Francis. I see there's a comment again in the chat from Emily. I'm sure everyone can see it, but maybe I'll pass it over to Emily to just articulate it to the group.
Poor thing, slow on the mute button there, sorry. You were doing just a quick oversight here of the three areas. As I recall, the first section when you were talking about locating critical minerals as a key step, and as I recall, that was focused on low impact exploration, which is excellent. But what about before that? So mineral potential mapping, understanding distribution of critical minerals subsurface. I'm sure Evan Oravan and Yao on the call could ask that question much better than I could. But before people pick up a shovel and start exploring, what is your initiative doing to get data transformed in order to understand mineral potential across the landscape, and specifically where critical minerals are?
It's great. Maybe we'll throw it over to Evan and Yao to articulate what they're doing in this.
Throwing you on the spot there, boys. Sorry.
Evan, do you want to start or you want me to start?
Yeah, I'm good. So what exactly would you like to know on this again, Emily?
I think that what I was sort of asking the Digital Supercluster group is the role that they have in that early data transformation and understanding subsurface interests. I know what we're doing on our end, but I guess I'm a little unclear about the intersection between our areas. So I know what us as the province of British Columbia is doing to try to get our data ready and to understand subsurface critical minerals. I guess and maybe you could speak a bit to what we're doing, but I'm a little unclear about pre-exploration and mitigating impacts through exploration. What is the Digital Supercluster doing in terms of digital data transformation and things like that? So maybe Evan, like just a really brief summary of some of the mineral potential mapping efforts we've been trying to work on.
Sure, yeah. So I was hired on initially at the BC Geological Survey to conduct mineral potential mapping of British Columbia, and we focused on a few mineral systems that contain critical minerals. That was just more or less by chance. So copper and nickel, I mean, they're not usually, or in the past, they weren't flavored as critical minerals. They're just popular mineral systems. And so you can rebrand them, fortunately, in the critical mineral sphere, because nickel and copper are important for green electrification, et cetera. But we've been using as much pre-competitive data as we can put together and integrate that in a modeling scheme for identifying the potential for a specific mineral system within British Columbia. But we've been restricted to date by looking at it bound by different traditional territories, but we're planning on expanding to a province scale. But from a province scale in itself for the mineral potential modeling doesn't even really make sense. It's sort of once again, an artificial boundary. What would make sense is defining regions where a particular mineral system might exist. So the whole arc assemblage of the Cordillera, for instance, which expands beyond BC up into the Yukon, Alaska, and down into Washington, especially looking for modeling porphyry deposits. So anyways, we're just working on ways to integrate a variety of data sets in order to model the potential for particular mineral systems of interest, and especially on a slant towards critical minerals, which is really a branding exercise anyways. And we were talking a little bit about hyperspectral frontiers here for critical minerals and digital information. And I'm an adjunct professor at codes at the University of Tasmania, sort of a world leader in economic geology. And they have a very large critical minerals project on the supply value chain currently. And one of the things that they've noticed, they're setting up some projects just that's industry and government sponsored to bolster the hyperspectral mineral libraries. So before we can even get into, even thinking about doing hyperspectral mapping, we don't have the libraries available to us now for some of the specific minerals that host some of these critical elements. So we're talking about like critical minerals, but most of these minerals are just elements that exist in minerals. And so we need to identify what those major minerals are based on mineral systems research done at the university or government or industry sponsored level, and then build those libraries and then engage in sort of hyperspectral work. And that can be included in the mineral potential modeling as well. So those things, if at a scale, a hyperspectral remote sensing at a regional scale can easily be implemented into regional modeling for mineral systems using modern mineral potential technologies, including AI and AI adjacent strategies, or data driven anyways. I don't know if that answered anything. That was a bit of a drunkard's walk, but.
That was actually very helpful, Evan. And I think maybe just to address Emily's question, and perhaps it's just a familiarity with how we operate. So we co-invest in projects that kind of follow particular trajectories of trying to expand upon data platforms and digital innovations. So in the mining sector, when we talk about the low impact exploration pieces, we've invested in our first fund in a couple of projects, one of which is in the predictive analytics side. So with a company called Ideon that you guys are probably very familiar with, and trying to kind of model out exactly where the deposits might lie and collect sufficient data samples in that without, affecting sort of the earth piece of it. But the other stuff is, I don't know if we've got Matt Murdoch from Earth Daily. Certainly Francis talked to this as well. We have a number of companies and projects that are tied to Earth observation, trying to look at different imaging data in order to do some predictive pieces and provide the basis of data towards the discovery efforts. We actually have some data commons projects, so this collection of different data sources in order to kind of get a better sense of the ore body that might exist in particular regions. Tech and do we have Janice? I think Janice from Brim, she might be able to talk more about this project, but there's a project about using the microbiome as possibly a way to not only deal with remediation of mine sites, but possibly in looking at biology as a method to look for new deposits. So possibly in terms of discovery of new opportunities there. A lot of the thematic things that we've seen in the past, which we'd like to carry forward, and this is why we're having this conversation, is what's the role of data? What's the connection point between different types of data? How can we organize consortiums to take advantage of that so that you can have cross-fertilization of the analytics in order to arrive at better sort of deterministic or predictive elements of where you might mine. So hopefully that answers your question, Emily.
I think on the way there, I think I'm definitely getting a sense of where you folks are working, and I think I have an idea of where we're working, and I'm excited to see perhaps how we can collaborate.
Yeah, just to be clear, it's not so much that we're working this. Like these consortiums are the ones that are working on it. What we do is we provide sort of the co-investment framework for that to happen. So unlike your team, we're not actually doing any of that in the supercluster, but I think many of the proponents that are in this call and other sort of projects, they're the ones doing that actual work.
And we do actually have Janice on the line. So Janice, if you can hear us and if you could pop on, it might be really enlightening for the rest of the group to just describe some of the work that Brim is doing, whether in the microbiome space or in other applications of digital technology in the critical minerals work that UBC's engaged in. Could you perhaps articulate that to the group?
Yeah, hi everyone. I'm here from UBC Brim and also the MICA. We're actually a regional partner as well for the Mining Innovation Commercialization Accelerator. So all of you who do have businesses and trying to move them forward, reach out for sure, as we are looking to help. And yeah, so on the Brim side, yeah, so what we do is we help to create those partnerships and catalyze things to go forward. And as Bill mentioned, the MMAP project is creating a library. So that's a platform essentially of data. And Carol, Carol Ann from Genome BC has been involved with the steering committee as well. So she can speak to a little bit more of that. But at Brim, we look for, what can make microbes and nature-based solutions as well. How can that help us to move forward? And microbes have a role in doing that. Microbes in the wild. And so essentially in this library, it's really creating a space for, yes, we're creating some DNA sequencing related to characterizing these microbes and their performance and the consortium, how do they work together, so that it can enable more usage, either playing defense and deleterious metals and materials coming out, or to play offense in terms of, hey, can we get critical metals actually out of this? And does this also connect to energy and innovations related to carbon capture and things like that? So it's opening up a platform that not only people can contribute their data with GIS data sets to the platform, but also it'll become available for users to use that library as well. So seeing, you know, what the BC, the Geological Survey, is doing as well, you know, we're trying to do that with microbes. And Carol Ann, did you want to comment further on that?
Yeah, thanks, Janice. I guess one of the big things that's important in this project is that, you know, when we have data platforms, often the issue is that we create this great data repository and we don't actually have an end use case in mind or end commercialization in mind. And this project is, you know, we have 3 potential investors, very large multinational organizations that are actively engaged in discussions for potentially having an equity stake in this joint venture. And so that's a really promising indicator that, you know, we have something that is going to be of value commercially as well as academically.
And that's yeah. And as you mentioned, that was a challenge, I think. I think that you mentioned there, Francis, in terms of how do we get that out there? Definitely.
So Janice, perhaps just because you mentioned it, if you took off your brim hat for a moment and put your mica hat on, in terms of the commercialization activities that are going in and around, in this case, you know, digital technologies, what are some of the challenges that you're seeing in terms of actually how do you know, the process of actually doing commercialization in the mining sector in and around this topic?
Well, as a partner, we're just really getting going. So I don't have the full picture yet, but we will be learning more about it. Anecdotally, from my personal contacts within the network, it's a similar thing where a lot of creators and innovators might have an idea, but necessarily who is the end user? This seems to be a common stuck point in terms of getting that perspective. And from a systems perspective, do we need to go directly at that, or are there adjacent ways? And should we be talking to other people or other industries? And that was the value, like with the MMAP project, you know, we are scaffolding on what Genome BC has and other partners from other industries on that one as well. So for critical metals, is there something in there that we can model that will not only that can help innovators on this front as well? So I don't know how widespread that pattern is yet, but it's just something that I'm watching for in terms of stuck point. People are reporting there's money available, but how do we create the connections and to understanding where is the need and where's the readiness in terms of customer, problem aware, solution aware, or pain aware. So that's what I'm mostly seeing.
I see Emily's got her hand up and ready to jump in. Emily, was there?
Perhaps I'm confused. I don't quite understand what we mean in terms of identifying an end user. Isn't that just mineral exploration companies that would use this data to find rocks? Like, am I missing something? Like that seems like the right end use, right? Like folks who use data to find those good rocks so that we can mine them.
Yeah, it's not even so much, you know, just simply identifying who might find this data interesting, but we want more than finding the data interesting. We want people organizations who will pay for it, that there's enough value there, that it's not a passing interest. It's just like, we actually need this data. And so, you know, just having the data there, there's still got to be some commercial pull. Like, like coincidence of these certain bacteria in the mine site, is that enough? So we actually need to, we've been developing 3 use cases to try to get enough commercial pull that organizations will go, wow, there's enough value here that I want to be subscribed to this. I need to have this information.
I suppose I was thinking less so on microbiomes and more so on some of that data that was discussed in terms of identification of location of critical minerals, because that to me would seem like a straight shot, like, right, Mineral X, there's your economics, there's your, the cost outcomes, or groups that speak for those organizations, like the Association of Mineral Exploration of BC, don't have as much to say on the microbiomes, but in terms of end use for things that help identify where critical minerals are, I think the mineral exploration industry is a straight shot answer.
I'm curious about that idea that as well, Emily. I have 30 years on the exploration side, working for a variety of companies. And my experience is there can be loads of information and data and tools out there. And depending on market conditions, and also let's not forget about the flow through incentives, which we often don't talk about, doesn't necessarily make it the pain that they need solved at that moment. All right. So there can be a lot of distractions and a lot of noise that don't have people looking at these solutions. So the need isn't necessarily the want isn't there in the moment. So we can't really say, oh, just get that all out there for explorers. I mean, to me, a big piece that we're missing is actually looking at overall performance related to all of these financing incentives that we put in. There's nothing attached to those at all. So we can't actually see how much better are we doing. And there's digital tools available to actually do that. And once we start making it transparent about how we are performing, maybe that can help for the pain to become visible as investors start to see that, hey, these companies aren't learning. They're just doing more drilling because, hey, we've got an incentive for critical metals and they've got a little bit of cobalt in that project. But are they actually advancing us towards our main goal when the government is trying to steer us towards some, probably there's some higher value opportunities. So can we influence the system with some other tools? So
I was just thinking, maybe I'm a bit confused as well, thinking about this. So maybe we need to look outside of Canadian perspective. But moving here from Australia, the mineral exploration industry there very much understands the importance of underpinning technologies and puts a lot of money into research and innovation through the universities. And they recently used mineral potential to discover a super giant critical mineral ore deposit in Australia. And that's being, so companies are investing a lot in the mineral potential and using companies like Canex and Gold Spot Resources to use AI and mineral potential techniques to aid in their exploration. So they're very much putting a lot of money in this direction in other markets. And that's what I assumed would happen here as well. So maybe it's just a matter of advertising what it is that we're trying to do and talking to the mineral exploration industry a little bit more and catch up to where Australia is.
Great points, Evan. Janice, I'm curious, you mentioned tax flow through credits and metrics of measuring change or success. What kind of metrics are you envisioning?
Well, I don't know, that remains to be seen. That actually would require a discussion, I think, between stakeholders, because you might see, it's very common to say, well, look at, we've drilled 10,000 meters, or if you look at government metrics, how many meters were drilled or how many dollars were spent in these communities and all of that. But how many questions were answered? If we can focus in on metrics that might show us about learning, how fast are these companies learning? Are they shutting down their experiments faster, right? Not just going towards, but we got to kind of see the edges as explorers. And I can't say specifically, but, you know, drilling with respect to what? How much money spent versus how much learned, right? Did you learn faster? Even if you look at your deployment of technology out in the field, you could ask, our investors asking, well, how do you make decisions? And how do you share your data? And where are your feedback loops? What are they looking like? So there's all different kind of, there's qualitative measures that you can do. And I mean, we know this, the people on the ground have qualitative stories, and there's technology that can actually map that can contribute as well to knowing the performance of a company beyond the use of technology, because some of them are using all the technology in the world, but are they learning fast enough? So I'm not sure what they would specifically be, Emily. I think that's a great question for us to be asking.
Thank you, Janice. That was awesome, and flagged it for our minerals economist on the call.
One thing I do want to orient around the questions that Evan and Emily have been asking, and Janice, thank you for kind of providing a bit of a voice on this, is like we put this particular area of focus up as a hypothesis just to see if there was something that you know, was worthy of pursuit here. And it's really like following the breadcrumbs from some of the projects we've invested in just recently over the last couple of years. But if the answer is nope, it's all been solved and there are no digital innovations that are needed in order to do this, and you know, we have got lots of other areas to kind of pursue. So not to pour water at all on this conversation, but in answer to your question, Evan, of isn't this already being done? Well, that's why we're asking. You know, if there isn't a case to be made that Canada can develop new digital innovations that will improve the discovery and sort of the refining and use of critical minerals, then hey, we can apply those resources in other areas. But I want to come back to, well, are there areas where we could invest incrementally in this? And if so, what would they be?
Yeah, I think Elizabeth, you got your hand up.
Yeah, so this is kind of an area that Foresight's been working in for a while, just having closed the challenge with the Mining Association in British Columbia. And that one was specifically focused on reduction of water, but there are a number of other mining technology companies that we're working to accelerate at this time. But I think the biggest challenge, or maybe the biggest kind of blind spot for me around this opportunity is sort of to what end? You know, co-investing in projects is great, but really, who's the project going to benefit? Is it kind of local communities, the mining industry as a whole? If they're successful, you know, how does this model get replicated across the country? Are we leveraging the provincial cap tables to kind of assess priorities by province or by market? And then, you know, what happens to the key findings at the end? Like, is the hope that this accelerates startup businesses, or that this is increasing industry adoption? Because I think there's still some regulatory challenges that we need to kind of overcome collectively to actually have industry adopt some of these newer or perhaps unproven technologies that will accelerate that critical mineral exploration and strategy.
Gordon,
I know that was a lot, but
yeah, I can't find the hand to raise. I've just got the session notes up here, and I don't know where it's disappeared, but I'm just jumping in. So if you're talking about digital data, you first got to define what data is available, because you need the data first to present it differently. And before you present that data, you'll have to break it down into what, if you're talking critical minerals or elements, those elements are constrained in a variety of deposits, so geologic systems. So you have to figure out what data you want to present, group it, and group it by element or critical mineral, and group that by the type of deposit and make that information available. That would be useful to explorers, but you'd have to outline a pathway to what you want to present and what data is available. I don't know whether Evan would have any comments on that, but feel free to jump in.
Well, unfortunately, I missed that.
Oh, okay.
I just stepped out to get for a cuppa.
Okay, I was just saying, Evan, that the idea of using digital supercluster, the idea of data, the first step would be defining what data is available to present, but that data would have to be related to the systems for the critical mineral / element that you're looking for and broken down. If somebody's looking for porphyries with copper, which is on the list, that's completely different than somebody looking for carbonatites with rare earth elements. So you would need to break it down into parcels for the exploration community if you're going to create some sort of digital database to be accessed. And the main thing is what digital or information is available to present digitally.
That's absolutely true. So the digital information in the mineral systems world is horses for courses. So different critical minerals occur in different mineral systems that require different levels of information to model it. So being able to organize information or organize this data would require a huge review and a lot of mineral systems research and updating our understanding of mineral systems to include critical minerals. We don't even have that yet. We don't even know. It's critical minerals is like a hot buzz term that's being included in all of the major jurisdictions now, but we don't have the economic geological legwork complete. So any sort of, if trying to figure out what digital information we need, there needs to be a geological theoretical study needs to catch up first. And so if you look at many of the major worldwide projects on critical minerals and data now, they're like multiple phases. And so like, for instance, the BCGS is putting together this 3-phase project on critical minerals. And the first step is inventory. We don't even know what we have. And then the second phase is knowledge. So we need to bolster our understanding of mineral systems and their capacity to hold different critical minerals. There's many of them. There's like, depending on which jurisdiction you're from, there's 20 or there's 30. That's a huge amount here. And they all behave, well, some behave similarly, but they can behave differently. And differently across different mineral systems. You can have copper in like 5-6 different mineral systems types, and they all behave differently. So like one modeling technique or one set of data might not even be appropriate between different copper systems. So yeah, absolutely, like an inventory and a review and really thinking about what kinds of data would be useful. And then there's another problem of that I see all the time is how do we store and implement the data that we're collecting? And how do we get people to understand even how to use them, to use that information? So I don't know if that answered any or built on anything you said.
You know, we've had a number of projects, Evan, where you know, the essence of these data ecosystems is to create you know, ontologies, nomenclature, some normalization of information, coupled with standardization. But a lot of the power has been not just a simple aggregation of it, but also across domains. And so in some cases, you know, it's public-private data, different use case stuff. And so there have been, you know, Caroline's been involved in some health-related projects that do exactly that. And we've had projects in the industrial space that do that. So, you know, in the mining area, it sounds like there might be opportunities to do some of that just in terms of shared information. Some is open, some is not, but ultimately to find better methods for these sort of analytic tools.
It's Yao Cui here. Can I jump in? Just make a couple of follow-up comments. Yeah.
Yeah, please do.
Okay. Yeah, Yao Cui, I'm the director for resource information at the BC Geologic Survey. And I think it's great to hear some of the technology, the development in the microbiome, and some the idea on using the Cosmo like ray, like detecting those ore bodies. Those are great things. And also the kind of work Evan had done in BC in the pilot project. What struck me is the data we have in British Columbia, especially the BC Geological Survey managing the public geoscience. I think you're absolutely right. We should be working on our inventory. So what we have here today is a bit of a pyramid. So on the top is the knowledge we have captured in terms of reports, database, and some publications. What we are a bit of a really lacking is the from those even current knowledge, tracing down to the observations, how those knowledges were captured or were formed, because we have been in the business for the last 127, 25 years. So there are a lot of geologists working in BC, and plus the from industry as well. So lots of knowledge being captured in the form whatever we have our hands on. But the majority, I would think 80%, 90%, those at observational level, those are either hard copy or locked up somewhere, not accessible. So it's great to hear developing some technology, algorithm, AI. However, if you send your AI algorithm to work on the knowledge we have captured, I don't think the AI is going to learn much. What really helps is going down to the lower level, the pyramid at the bottom, the observational data, which has pretty much locked up in the hard copy. So in terms of extracting, what are the essential data we should be extracting, how to extract, once extracted, what kind of form, as Bill mentioned here, some kind of ontology, cross different discipline. We're talking about the bedrock geology, geochemistry, geophysical, mineral systems, how things are how we be able to communicate to share those data. There are some open standards out there. So my question here to the digital technology supercluster, I think number one is it's across it's a nationwide. So in terms the coordination, so we know we're not going to be repeating some of the efforts. If certain things happening in certain area, perhaps we should be informed somehow. I think this is great. This workshop, it really helps. There's talents, people bringing this workshop, bring people from different areas. That's great. I like to hear more, like going down the path, like we get informed. All the people dealing with data, in our case, public geoscience, which to me is essential for the future, for anything like not only just like a critical mineral, any deposits, any resources in the country. So so we don't end up like repeating and doing the same thing over and putting different efforts. So there's some coordinated effort. To me, it's essential. And yeah, perhaps that's what I want to some follow-up comment here. Thanks.
Yeah, so thanks, Yang, for that. I think, one of the observations on how we've traditionally run projects and governed our projects is to take as much of a value chain approach to holistic value chain approach to it by ensuring that a consortia, really represents everything from idea creation, talent development, through product development, commercialization, productization, early commercialization of that technology with customers, and ideally with industry and trade associations who help amplify what's going on in those consortia. If you look at the size of our consortia from cycle one, I think we average 4 or 5 organizations per consortia. Now we're double digits and up. So we do try within our model for innovation to try and capture as much of the value chain, as I said, from idea to really amplification at the industrial level to capture that, so we don't duplicate efforts, that we have the best practices of the industry in mind, that it's not hidden on a back shelf, non-digitized somewhere that it can't be reused and exploited for other purposes by the partners. So that is built into the model by which we actually invest in, and the partners that we try and bring into projects. So yes, we're a co-investor in projects, but we do help try and fill gaps in consortia as well, where we believe there's perhaps a deficiency. And guess what? A lot of the time it tends to be on, channel partners that help magnify the impact of the digital technology more broadly. We see a lot of use cases over and over again, use case development, but that can only go so far in terms of actually developing a digital innovation that gets to market and has the potential to grow and realize the revenue potential that we really want to deliver. So to answer your question in part is really to look for those consortia that represent the value chain, and in some cases that includes regulatory bodies, in some cases that doesn't, but really to understand how do we build as holistic a solution as possible, not just invest in a single technology provider with a single use case, but actually really carefully think about what the end solution looks like, and who needs to interface to that to make it successful. I see we've got a few things in the chat here. Emily and Janice, duplication of effort, stakeholders. How can we support those stakeholders? Who needs to pivot or shut down their experiments? I think this idea of failing quickly is all one that a lot of people appreciate and identify. We do try and typically find those projects that have had early validation. We do tend to have kind of larger scale projects where there has been a momentum built around them, and a core group of interested parties who are willing to build that out. Like I think about the IDEON project and where that started, and then ultimately where it's landed with the partners that are around that table, which is fantastic, having those top tier partners in that group. We have had experiences where we have had to where projects have shut down because they haven't met milestones, they haven't been able to demonstrate their ability, having strong innovation practices to ensure that we all know what we're marching towards, and if failure happens, it happens, and that there's protocols for that. So having that clearly set out in master project agreements certainly help. But also to think that these things are not failed exercises. We learn from them and we can apply them in other areas. And it's part of the cluster magic, if you like, is that one technology in one particular area actually might not work, but in an analogous industry sector or use case, it might be very, very, very effective. So we try and keep that knowledge within our cluster through things like our IP registry, and through our regular reporting on projects as well. So, keeping that, that technology and that innovation alive is a large part of what we try and do, and make it transparent for people. Bill, I'm just looking at the clock here and just cognizant of the time. Was there anything you wanted to wrap up with?
Yeah, thanks very much, Ian, for that. And I think there was a robust conversation just to maybe in some respects get people oriented in terms of what we might be looking for. I want to come back to Elizabeth's question, but to what end, and make sure that we all are calibrated around that. Our co-investment model is really about investing in new R&D endeavors, which result in new products. So ultimately, we're about helping industry and academic consortiums build and develop new product innovations that could ultimately be deployed into commercial endeavors. And so the way that our collaboration framework works is we try to tie an industry partner right from the very beginning. So there's an assured pathway to commercialization right from the get-go. And so the project that Janice described earlier has tech resources and a host of other mining companies involved in that, because the commercial outcome of that library is a set of subscription services, a platform that they will actually adopt and buy. So that's what we're looking for in these innovations. Today's conversation kind of illuminated there is opportunity in terms of maybe some of the core analytic pieces, or at least the data gathering and the combinatory effects of trying to pull different sources together. in particular, I came away understanding that maybe we've got to get to more root level information in order to kind of train new engines and new discoveries. There's clearly similar pathways for kind of ensuring that we've got nomenclatures right, and that the drive towards, well, how will people use this in a platform format so that they can actually improve the rate at which they can either discover or make use of data to affect sort of more efficient mining practices, is something that we can consider. But I certainly would welcome everyone's input after the fact. Just emailing us. I could be reached at btam@digitalsupercluster.ca, and Ian similarly to ievans@digitalsupercluster.ca. And we'd love to hear more about particularly where you think we might have areas of investment opportunity for new projects that could be at scale. So certainly there's a lot of great things that are happening. I appreciate the lessons that maybe we can borrow from Australia and how we can apply some of this universally across Canada. And thank you very much for all of your insights. Emily, you have the final word.
Not intending to, so sorry. I think just one note to add is that the geological surveys are your friend. So across the province, across the country, there are folks who are the regulators of the mining activities, but there's also those geological surveys that are embedded in each province and at the national level as well. And those are the holders of the data. So when we're talking about foundational data, those are your buddies.
Great. That's a great note to end on. Any other comments or anything from anyone in this chat today? Okay, if not, I want to thank you all again for taking the hour to chat with us and sharing your ideas. Have a great day, everyone.